Hello students, let's do some acceleration practice problems. So we've got our two problems here. The first one is about a car driving to school. It increases its velocity from 15 to 20 meters per second and only takes 3 seconds to do that. We want to find the acceleration of this car. And the second problem, there's an apple that's fallen out of a tree and it hits the ground 1.2 seconds later. And we want to find out what speed did it hit the ground. So we'll go through both of these types of problems. They're both acceleration problems. We'll use the problem-solving steps. So if you need to pause the video so you can copy these down, then you'll want to do that right now. Okay, let's do the first problem. So we'll do number 1. And for this one, it says that we started with an initial velocity of 15 meters per second, and we went up to a final velocity of 20 meters per second. And we did that in a time interval of 3 seconds, and we were asked to find what the acceleration is equal to. Our equation for acceleration is a change in velocity over time. Anytime we have a delta v, we want to expand that delta v. So for this problem, a equals final minus initial velocity over time. And that will be the case for any time we have a delta. It'll always be the final minus the initial. Now that we have our equation, it's simply a matter of putting the numbers in with their units. So we have 20 meters per second for our final speed. Initial is 15 meters per second. Let's fix that S. Fix the S. There we go. And the time was 3 seconds. So you can always use the calculator for this part. And we see that we get 17, and the units are meters per second squared for acceleration. So this is our answer for the first problem. The acceleration is 1.7 meters per second squared. The second problem is an apple falling out of the tree. So an apple that's falling is initially at rest in the tree. It's just resting there, hanging there, so initial velocity is 0. For this particular problem, it said that our time interval was 1.2 seconds. That's how long it took to hit the ground. Now, since we're falling downward, our acceleration is actually gravity's acceleration. So I'm just going to make a little note that this was gravity's acceleration. And gravity's acceleration on our planet is 9.8 meters per second squared. You could also use 10, and you get pretty close to the same answer. And we were asked to find what is the final velocity. In other words, what is the impact velocity as the apple hits the ground? If we take the equation that we have in the first part in the box over here, and we start from this, we have a equals final minus initial velocity divided by time. This is a good starting place if we need to use some algebra to rearrange this, because for this problem, our unknown variable is final velocity. So we want this to also read VF equals. So what I'm going to do, I'll change the color for this one, is I'm going to multiply both sides by delta t. And you can see that by doing that, the delta t's here cancel. And if I rewrite this equation, I've got a times delta t equals VF minus VI. And then what I can do from here is I can solve this for final velocity by simply adding initial velocity to both sides of the equation. And when I do that, cancels over here. And I have on this side a delta t plus vi equals vf. I'm just going to rewrite it the other way. Final velocity equals initial velocity plus a times delta t. So this is the equation that will solve this problem. Let's put the numbers in. So final velocity equals, well, we started from rest, so the initial velocity is 0, plus the acceleration was gravity's acceleration, 9.8 meters per second squared, and I multiply that by the time that it took to hit the ground, in this problem, 1.2 seconds. And when I do that, I'm going to round up for this one, and I have 11.8 meters per second. And I'm using meters per second because this is the units for a velocity. You can also see if we look at the units, that one of the seconds here would cancel this one. Sometimes we need to use a little bit of algebra, but if we look at this part of the equation right here, this is a good starting place. It's a good starting place because from that part of the equation, what I can do is I can get to other forms of this same equation. So the first one is what we did in number 1. We've got A equals final velocity minus initial divided by time. I can also do a little bit of rearranging, so I get another version of this equation, and I simply would just swap the A and the delta t. So if I needed to solve for a time interval, delta t equals final minus initial velocity divided by A. We've got the other version which we used in number 2. Final velocity equals initial plus A times delta t. And then the last version for this equation would be initial velocity equals final velocity minus A times delta t. So we have 4 different versions of writing the same equation, and depending on what our unknown variable is, will determine what I need to do to rewrite this equation. Sometimes we've got algebra that we need to use, sometimes there's other tricks, like the triangle trick that we talked about in class. So there you have it, 2 examples of how to solve an acceleration practice problem. I'll see you in class.